Ever since the beginning of the computer age, people have been working on making them intelligent in the same way that people are intelligent. By the 1980s, quite a bit of progress had been made, and there was a surge of interest in AI. There were two primary technologies available then, neural nets and expert systems. I built prototype applications using both of these technologies, and as a result of that work, I began to think about the idea of multiple model AIs, which would combine both neural nets and expert systems. Later on, I began to speculate about what it would take to create a human-like intelligence. In recent years, new technologies have been added to the toolkit, including machine learning and natural language, where significant breakthroughs occurred in the early years of the 21st century. The problem with AIs is that they tend to be idiot savants. They may be good at doing one task but have no other capabilities. All of the brilliance those systems display comes from the people who build them. The AlphaGo machine is an example of this. It recently defeated a man who plays Go at the master level, and that is impressive. However, people have been playing Go at a high level for centuries. At the same time, these people can do many other things that people do in life, such as chopping wood and carrying water. AIs also have a problem with failing when presented with edge cases. One example of this is the fatal crashes of Tesla cars due to weaknesses in their autopilot system. What might a multiple model AI look like using current components? It might have an expert system at the center, or a neural net, or machine learning, or natural language. And they could be configured in networks of various types depending on the situation. Financial instruments of various kinds are one potential application for multiple model AIs. Derivatives are one example of this. A derivative is typically made up of groups of other financial instruments, such as mortgages. It is a step-by-step process that must be done correctly to deal with the legal, financial, and regulatory issues that are involved. Another aspect of creating a derivative is predicting what might happen to the derivative once it is placed on the market. Each one of the tranches could be analyzed as well as the whole derivative, while keeping in mind the company's appetite for risk. How would these systems communicate? In the human brain, the neurons communicate by forming connections with other neurons. Information in the form of chemical signals is passed through the synapses. In computer systems, the APIs are the equivalent of the synapses in the brain, and they can transmit information such as numbers, text, images, and concepts, which takes us into the world of the Semantic Web, where there is a huge and growing amount of information available. There are also other types of semantic tools such as the financial reporting ontology, which can be used by organizations to pull scattered information together into a more usable form. Another use for layered AI systems is in reducing the complexity of information. In any large organization, the amount of information presented in dashboards can be overwhelming. All of this information could be fed into a set of neural nets and then refreshed frequently. To produce a more manageable, near real-time view of the enterprise. With any AI, there is the risk that they will make mistakes, either in the form of false positives or false negatives. This might be reduced by giving them a measure of common sense. Common sense is one of the long-standing hard problems in AI, but progress has been made. One example of this is a system called Psych. This has been under development since 1984 and now has 1.5 million terms. In spite of our best efforts, there will always be some residual risk, which is why we need to keep an eye on them. We may also want to give these systems the ability to create new nodes. These would be similar in function to the silicon gate arrays we use in hardware. Although I don't think this brings us up to the level of human intelligence, I do think this increases the potential power of AI systems by combining human control with a combination of neural nets, expert systems, natural language, machine learning, the semantic web, common sense, and even the Internet of Things into one interacting system.